Hi, I'm Randy Becker, and I'm an application engineer at Keysight Technologies. In this demo, we'll be using the VXG vector signal generator. As you can see, it has two channels. Each channel can go up to 44 gigahertz. Both channels support high output power capability with great EVM performance, and each channel can support up to 2 gigahertz of bandwidth. In fact, you can actually bond both channels together to give you a contiguous virtual 4 gigahertz wide channel when you need even more bandwidth. The signal that we're going to be using today is a 5G new radio signal, and I'm going to use the built-in Signal Studio application to generate that signal. So I do that by clicking on the signal block, and I can edit the signal. On the bottom of the screen, you can see the distribution of resource blocks across time and frequency, and you can see I have a variety of different channels with different modulation formats. You can come in here and edit and change any of the parameters to suit your needs. Let's go back to the home screen. You can see that each channel is configured for a frequency of 2 gigahertz, which is perfect for FR1, and an output amplitude of 0 dBm. Each channel is connected to a different analyzer, one channel going to the PXA and one channel going to the UXA. So now let's take a quick look at the PXA in more detail. On the screen you can see the spectrum analysis application running, sweeping from DC basically all the way to 26.5 gigahertz. You can see my new radio signal there at 2 gigahertz. And let's just take a quick look at a couple of different things. You can see here that both the internal preamp and the internal low noise amplifier are both available. You can use them individually or in combination to better optimize the instrument for the signal of interest. Particularly if you're making low-level spurious measurements, you might need those tools, and now they're available in the PXA. You also have access to setting up multiple tabs, so you can do multiple measurements very easy and quickly. I'll just switch over to the second one, where I'm making a 5G new radio channel power measurement. By clicking on that, like all of the X series applications, I can access any of the different apps like 5G new radio, LTE, wireless LAN, and beyond. I also have access to the different measurements like channel power, ACP, occupied bandwidth, EVM, etc. So those are all available as a single button press. And I can even launch the VSA software, which is what I'm going to do now, and we'll take a look at the EVM performance using the VSA software. So now we're going to take a look at the EVM performance of the PXA and compare that to the UXA. So I'm running the same instance of the VSA software that we saw before, but I've opened an additional window and added some additional measurements to that. And I only have 3 measurements in this particular window, so we can see the EVM clearly. On the PXA, we can see the EVM is right around 0.33%. And then if we look at the UXA, the EVM is right at 0.32%. So that's a great result for this 100 megahertz FR1 new radio signal with a variety of different modulation formats. Both instruments performing virtually the same, so the PXA is a great choice for sub 26 gigahertz work. In summary, we looked at the VXG and how we can generate 5G new radio signals, and then we looked at the performance of the PXA and compared that to the UXA class analyzer. The PXA offers a lot of great performance, very similar to the UXA, but for those sub 26 gigahertz applications, and still gives you access to all of those X apps. It also comes in a smaller form factor, as you can see here, which is great for some of those benchtop applications and also in rack mount situations.